Hi, so today in this video we're going to be covering the factoring review for our College Algebra 1050 class. Now, throughout the semester, when I'm doing problems, I will be looking from the textbook, but I will be finding either similar problems or making up my own instead of just copying the exact problem, since the point of these videos are not for you to have a homework cheat or like a homework key, but more so to help you understand a little bit better and help the material come a little easier to you. So if you see that the problem numbers are the same, like for instance I do 13, 17, 18, etc., these are not the exact problems, but they are going to be very similar with the methods that they're going to be solved with. With that, let's begin. This is our factoring review. So there are a few methods of factoring, but we'll cover them as we move along. So in this one, it wants us to factor out the common term. Now it looks like 3x and 6 don't really have a common term together, but 2y minus 4 and 2y minus 4 are the same. So what we can do is, technically what we're doing is we're dividing both sides by 2y minus 4, which is 2y minus 4, and we're taking it out, leaving us with our 3x plus 6. What makes it easier for me to remember is just we're going to snatch these up and then put them on the outside. They need to be separated by a plus sign though. So yes, we basically, we have these two in common, so it can be dropped here, and then these two in common, so it can be put in here, whatever's left over. So basically, you just take out whatever's common. This one wants us to factor the trinomial. Now, there are a lot of methods to factor trinomials and polynomials in general. I have a video that goes over those methods, and I will link to it in the description. But for now, I'm just going to do the method that makes the most sense to me for each problem. In this case, I'm going to use the Hippobuts method, which is covered more in depth in that video that I'm going to link in the description. It allows us to take our a term and our c term, so it's ax squared plus bx plus c, and we're going to multiply our a and our c together, which is 1 times negative 8, which leaves us with negative 8. Then we're going to find factors that multiply to negative 8, but add up to positive 2. My guess is going to be that it's going to be 4 and negative 2. So we can draw our little Hippobuts. We'll drop an x in both, and then plus 4, we'll drop that guy in, and then minus 2, we'll drop that guy in. This is fully factored. This would be the answer that it expects. Loop, hold on. Next, we have 3x squared plus 2x minus 5. We still want to factor this trinomial. I'm going to be using the AC method. That is when we take our a and our c term, which is 3 and negative 5, and we multiply them together, giving us negative 15. Then we're going to find the factors that will multiply up to negative 15 but add up to 2, and that will be probably positive 5 and negative 3. And instead of just doing Hippobuts, because we can't fully do that yet, we're actually just going to break this term up and replace it with this. So we have 3x squared plus 5x minus 3x minus 5. Now, the reason why we can do this is because we're not technically changing the values. If we were to combine like terms at this moment, what would happen is you would just have this. We aren't allowed to change the value of our equation. When you're done factoring, you should be able to take your terms that you factored out and multiply them together and get what you had originally. So now we'll do factoring by grouping. It looks like this has an x in common, so we'll take an x out. We've got x, leaving us with 3x plus 5. Then we can take out a negative 3 here. Nope, sorry, just a negative, which leaves us with positive 3x plus 5. Basically, our goal is to get us in a situation like this original, where we have both of the same terms on the inside. So what we can do then, let me move this problem down a bit. My bad. Oh, wrong layer. Whoops. Hold on. Yeah. So basically now what we can do is we can take this out. So that leaves us with x minus 1, because we took out a negative 1, and then multiplied by 3x plus 5. If we were to multiply this out by FOILing, it should give us our original equation that we started with. I'm going to give myself more room with this one because I kind of went over with that. Whoops, hold on. So this one we've got 5x minus 7x minus 6. Again, I'm going to do the AC method. So 5 times negative 6, which is negative 30. 10 and 7 are both factors of 30. I want negative 7. However, that's not going to be what I want actually. Hold on. Let me do some thinking. So we've got 10 and 3. Yeah, and that will give us negative 7 if we do negative 10 and positive 3. So we'll do 5x squared minus 10x plus 3x minus 6, and we can do factoring by grouping again. These terms have a 5 and an x in common, so I'm going to take a 5x out, leaving us with x minus 2. And then these have a 3 in common, so I'll take out a 3, leaving us with x minus 2. Then we can do what we've done before and do x minus 2 times 5x plus 3. That would be factored. Moving on to number 23. This one says we are going to be using the, what's it called? I don't remember what that acronym stands for. I wrote it down when I had the textbook open, but I don't have it now. It's probably something like perfect squares, something with of squares. And it doesn't matter too much. Basically, what we're looking for when we see something like this, there are a few hints that we can see when we're factoring, when we want to use the perfect square method. So first off, we want no b term. We don't want a term that is just x. And that satisfies this equation. We also want a negative. It doesn't work with a positive in between the two. It needs to be a negative. And then lastly, we need our two terms to be perfect squares. So if we square rooted this term, and if we square rooted this term, we would get 8x and 9. No, sorry, 6. 6 times 6. And now what we can do with that is we can do 8x plus 6 and then 8x minus 6. Now if we were to multiply this out, we would get 64x squared minus 36. Basically, you square root them, and then you have your little hippo butts, and you take whatever your square root term. This is technically referred to as a, though I think that gets confusing because we're not talking about just the 64. We're talking about the whole term, and then you just plop them in. So 8, we do a plus and a minus, and then a, and then your b. And we'll rename this to b. This one is also a perfect square, though this one tends to confuse some students because they see this negative 2, they see this x squared after the 16. Now, we actually can still work with this. We don't want to rearrange it into standard form because this is already in our perfect square factoring form that we need it to be in. So let's square root both terms. We have a negative here, so it's allowed. Well, it's going to let us use the perfect square method, and we'll draw our little parentheses, and we'll do a plus and a minus. Our first term is going to be 4 because the square root of 16 is 4, so we'll drop a 4 in both, and then the second will be an x, and that would be it factored. This next one says factor by grouping. We've got 4 terms now, and one of the first things that we feel like we want to do initially is to take out like a greatest common factor. However, this problem, none of these have anything in common. So what we'll want to do is we can actually treat it very similarly to what we did before with our factoring with the AC method, where we split it apart like this, where we basically draw a line in between the two groups, and we say, okay, we're going to take this one at a time. What if I take this out? What do these have in common? These both have a 9x squared in common, and that will leave us with a 2x plus 1. And then what does this have in common? Nothing, but it actually works out really fine because it also is 2x plus 1. We still need the insides to be the same. But now what happens is that leaves us with, and then plus 2x minus plus 1. That leaves us with 9x squared and then 2x plus 1. And then normally you would put something in parentheses there, but since it's just like plus, sorry, my bad, it'd be plus 1. My bad, not just 9x squared. Whoopsie. So 9x squared plus 1. You can't just have nothing there. And then if we were to FOIL that out, whoops, that would give us 18x cubed plus 9x squared plus 2x plus 1. Yep, that is what we started with. And if you're confused by how I did that, I just did like the FOIL method, which is, or like crab claw, I've heard it be referred to, where you just multiplied 9x squared with each term and then 1 with each term. And then combine like terms, which this equation doesn't have any. Next is to factor. This one, I'm thinking I'll skip because it's very similar to both 17 and 19 that we did. So I'm going to skip this. It's going to be using either the AC method or Hippobutts, depending on what you're most comfortable with. I'm also going to skip 66 because it's the same deal. So moving on to 71, what's going to happen is, one thing that I noticed right off the bat is, well, first of all, my instinct is to take out the greatest common factor. But I don't actually want to do that. Oh, no, sorry. I do want to do that. My instinct would be to do the AC method without taking out the greatest common factor. But I don't want to do that because it will make my life easier if I can just take out what they have in common. And this should be a y. My bad. One sec. I wrote it down wrong. So these all have a 2 in common. And we always want the first coefficient to be positive, our leading coefficient to be positive. So we'll do negative 2 times y squared minus plus 6 minus 36, 18, my bad. And this should still be 6y. Now what we can do is we can ignore this negative 2 for a minute, but it's still important. We just don't need it when we're factoring. We can do the AC method here, or Hippobutts, which is basically the same in the beginning steps. So 1 times negative 18 is negative 18. We want to know what will add up to positive 6. And I think that 9... Nope, it won't be 9 and 2. Maybe 6 and 3. Hold on. Oh, I think I wrote this problem down wrong. I think this should be a 62, not a 32, not a 36. So this should instead be minus 16. I wrote the problem down wrong. And this will be either, so we have 2 and 8, and that looks like it's our winner chicken dinner, so we'll make this a negative 2. Then we'll drop down our Hippobutts, and it will be x minus 2, and then x, and we're using y, so actually we won't use x. Y minus 2, and y plus 8. And this negative 2 is still important. We can just drop them on the outside, because all of these are multiplied together. And that should be it. If you have any questions about factoring, please let me know. In this semester, we will be using factoring quite a bit, and it's just assumed that you already know how to do it so far. I'll link a more comprehensive video in the description below. Have a good one.